Hello, everyone, and thank you for being here. Today, I will talk about developing computer simulations with Swift. My name is Ryota Motonishi, and I'm an iOS engineer at LY Corporation. First, let me ask, are you familiar with computer simulation? For example, during the COVID-19 pandemic, you may have seen simulations like this. This is a computer-generated simulation. Surprisingly, simulations like these use only addition, subtraction, multiplication, and division. That means we can develop them with Swift too. Building simulations can be just as fun as creating apps. In this talk, I'll show you how to develop a simulation with Swift. Here is a simulation I created with Swift modeling a fluid. It doesn't use any physics libraries, just basic math to implement physical laws. However, developing this simulation is quite challenging. So today, let's start with something simpler, a spring with a ball attached. Let's go through the steps of running a simulation. Simulations work by advancing time step by step. At 0.0 seconds, the spring is compressed. The ball experiences a force from which we can calculate the displacement. Using this, we determine the position of the ball at 0.1 seconds. Repeating this process updates the position step by step, creating an animation. This is how it looks in code. The constants are ball mass, spring stiffness, time step, and spring's anchor position. The variables are ball position and velocity. The main calculations happen in just 4 lines inside update spring function. By calling this function repeatedly, we simulate the ball's motion. Now, let's break down the update spring function. The first line calculates the force applied by the spring. This follows Hooke's law. In the next lines, we update the ball's velocity. We compute acceleration using the equation of motion, then update the velocity. Finally, we update the ball's position. Multiplying velocity by the time step gives the displacement, which updates the position. By repeating this process, we can simulate motion over time. Now, we just add a Swift UI view, and we have our first simulation. This is one of the simplest simulations. But take it a step further. Let's take it a step further. This simulation I showed earlier follows the same basic process as the spring. However, it involves more complex calculations and many more elements. This video simulates over 6,000 elements, which is still a relatively small-scale simulation. Real-world simulations often handle millions or even billions of elements. The biggest challenge in large-scale simulations is the increase in computation time. For example, let's multiply 2 arrays, element by element. A common approach is using a for loop. But when I run this on my computer, for an array with 10 million elements, it took 13 seconds. This is quite slow and could significantly impact simulation performance. This is where Apple's Accelerate framework comes in. The Accelerate framework provides optimized tools for fast numerical calculations. Using Accelerate, we can replace the for loop with this vdsp.multiply function. The for loop originally took 13 seconds, while Accelerate finished in 0.014 seconds. That's nearly 1,000 times faster. This speedup is thanks to SIMD processing, and it clearly shows how Accelerate can greatly reduce simulation time. In this talk, I introduced how to build a basic simulation in Swift and optimize computation time using the Accelerate framework. I hope this inspires you to try your own physics simulations. That concludes my talk. Thank you very much.
Ryota さん